Let's say I have 3 particles on a coordinate system. At the origin, I have a 1 Coulomb charge. At 4 meters on the positive y-axis, I have a 2 Coulomb charge. And at 3 meters on the positive x-axis, I have a negative 3 Coulomb charge. What is the magnitude and direction of the force experienced by this particle? Firstly, notice that the force it experiences based on this charge is repulsive and downwards. And the force experienced by this charge is attractive and towards the right. We can calculate each of these forces individually and then sum them with vector addition. First, let's consider the forces in the x direction. We can solve this using Coulomb's law, which states that force equals k q1 q2 by r squared. We can plug in k as 8.988 into 10 to the 9 Newton meters squared per Coulomb squared. Q1 is 1 Coulomb and Q2 is minus 3 coulombs, though the order we choose does not matter. Divided by the distance squared, which is 3 meters. Plugging this into a calculator yields negative 2.996 into 10 to the 9 newtons. The negative sign indicates that the force is attractive, but since we already knew that and it's pointing towards the right, I will write Fx equals 2.996 into 10 to the 9 newtons with the positive sign so that we don't get confused about the direction. Now for the y component, we calculate the Coulomb force using the same formula. However, in this case, the two charges are the 1 Coulomb charge and the 2 Coulomb charge, separated by a distance of 4 meters. Plugging this into a calculator yields 1.124 into 10 to the power 9 newtons. Now, the positive sign here again indicates that this is a repulsive force, but since it's pointing down, I will write Fy with the negative sign. Now, if my forces point in the x direction and the y direction, I can find the magnitude of the resultant force by the square root of the sums of the squares of each component force. This is equal to the square root of 2.996 into 10 to the 9 squared plus negative 1.124 into 10 to the 9 squared. Plugging this into a calculator yields 3.200 into 10 to the 9 newtons. Then, to calculate the angle, indicating the direction, we use the arctangent, or inverse tangent, of the force in the y divided by the force in the x. Plugging this into a calculator yields negative 20.556 degrees. Thus, our 1 Coulomb charge experiences a net force of about 3.2 into 10 to the 9 newtons at about negative 20.556 degrees from the x-axis.